From our vantage point on Earth, the moon looks small. But if you were to hop in a spaceship, don a spacesuit and go on an epic lunar hike, how long would it take to walk all the way around it? The answer depends on myriad factors, including how fast you can go, how much time every day you spend walking, and what detours you will need to take to avoid dangerous topography. Such a trip around the moon could take longer than a year, but in reality, there are a lot more challenges to overcome. Today, we will discuss with you on the topic, how long would it take to walk around the moon? Welcome back to Signature's Life, and you're watching Signature's Science. A total of 12 humans have stepped foot on the lunar surface, all of whom were part of the Apollo missions between 1969 and 1972, according to NASA. The footage that was beamed back to Earth showed how challenging and apparently fun it was to walk, or more accurately, bounce around in the moon's low gravity, which is 1/6 the gravity of Earth. However, research from NASA has since suggested that it is possible for humans to maneuver much faster on the moon than the Apollo astronauts did. Theoretically, walking the circumference of the moon could be done faster than previously predicted. During the Apollo missions, astronauts bounced around the surface at a casual 1.4 miles per hour, otherwise 2.2 kilometers per hour according to NASA. This slow speed was mainly due to their clunky pressurized spacesuits that were not designed with mobility in mind. If the moonwalkers had sported sleeker suits, they might have found it a lot easier to move and, as a result, picked up the pace. In 2014, a NASA study published in the Journal of Experimental Biology tested how fast humans could walk and run in simulated lunar gravity. To do this, the team got 8 participants to use a treadmill on board a DC-9 aircraft, which flew special parabolic trajectories on Earth to simulate gravity on the moon for up to 20 seconds at a time. This experiment revealed that the participants were able to walk up to 3.1 miles per hour, otherwise 5 kilometers per hour, before breaking into a run. This is not only more than double the walking speed managed by the Apollo astronauts, but also fairly close to the 4.5 miles per hour, otherwise 7.2 kilometers per hour, average maximum walking speed on Earth, according to the researchers. The participants pulled off these fast speeds because they were able to freely swing their arms, similar to how humans run on Earth. This pendulum motion created a downward force, which partially compensated for a lack of gravity. One of the reasons the Apollo astronauts were so slow on the lunar surface was because they couldn't do this properly due to their chunky suits. At this new hypothetical max speed, it would take about 91 days to walk the 6,786 mile, otherwise 10,921 kilometers circumference of the moon. For context, it would take around 334 days to walk non-stop, that is, not stopping to sleep or eat, around the 24,901 miles, otherwise the 40,075 kilometers circumference of Earth at this speed, although it is impossible to do so because of the oceans. Obviously, it's not possible to walk non-stop for 91 days, so the actual walk around the moon would take much longer. One of the biggest challenges would be carrying supplies, such as water, food, and oxygen. I don't think you would be carrying them in your backpack, because that would be far too much mass even if you're at 1/6 gravity. Therefore, you would need to have a support vehicle with you. A lot of the agencies are looking into the concept of having a pressurized rover, which can actually support the astronauts when they're doing exploration missions, kind of like a portable mini bases. You could use that to go in at night and resupply, and then go back out during the day and walk around again. Moon adventurers would also need a spacesuit with a design that allows for optimal movement. Current spacesuits are still not created with excessive locomotion in mind, but some agencies are developing form-fitting suits that will allow for the arm swing necessary to walk properly on the moon. The moon's harsh topography would also make finding a suitable route around it quite tricky, especially with meteor craters that can be several miles deep. You would really want to go around the craters? It's just too dangerous. You would also have to factor in light and temperature when planning the route. At the equator of the moon, and during the day, you're looking at temperatures at around 100 degrees centigrade, otherwise 212 degrees Fahrenheit. And then at night time, it drops like to minus 180 degrees Celsius, otherwise minus 292 degrees Fahrenheit. The lunar cycle also means there are days when there is little or no sunlight, and at least half the journey would have to be done in the dark. Providing protection against these extreme temperatures could be possible with specially designed suits and the rover for protection, but the temperatures could also change the state of regolith, a fine grey soil that covers the moon's solid bedrock, and affect how fast you could walk on it. However, radiation could pose an even greater danger. Unlike Earth, the moon does not have a magnetic field that helps deflect radiation from reaching its surface. If there was no major solar activity at a time, then it may not be so bad. But if there was a solar flare or coronal ejection and you are hit by high levels of radiation, that could make you very sick. Solar flares and coronal mass ejections both release large amounts of energy and magnetized particles, but differ in the types of particles they emit, the duration of the event, and the way the radiation they produce travels through space. According to NASA, this type of mission would also require a huge amount of endurance training because of the demands of exercising in low gravity on your muscles and cardiovascular system. You would have to send an astronaut with ultra-marathon level fitness to do it. Even then, walking at a top speed would be possible only for around 3 to 4 hours a day. So if a person walked at 3.1 miles per hour, otherwise 5 kilometers per hour for 4 hours a day, then it would take an estimated 547 days or nearly 1.5 years to walk the moon's circumference, assuming your route isn't too disrupted by craters and you can deal with the temperature changes and radiation. However, humans won't have the technology or equipment to accomplish such a feat until at least the late 2030s or early 2040s. You would never get an agency to support anything like this, but if some crazy billionaire wants to try it, maybe they can pull it off.